are going to discuss the next chapter, that is chemistry foundation, and in this chapter we will learn how to make chemical formulas, how to balance the equations, how to make ionic equations, and after watching this lecture you will be able to differentiate between the types of chemical reactions. Okay, so let's start the chapter. Define the term element. What is an element? A pure substance in which all the atoms are same. So the next definition is a pure substance which cannot be further split or divided. Like Na, sodium, carbon, phosphorus, and etc. Okay, so the next subtopic of this chapter is we have to know what is a mixture and what is a compound. Okay, so first discuss the mixture. It is formed when two or more than two substances physically combine with each other. Means they are not chemically combined. They can be separated by simple distillation, simple separation techniques like evaporation, simple distillation, and etc. Okay, there is no fixed ratio by mass among the components of a mixture. Okay, like they are not specific in numbers. Mixtures have no chemical formula. They are not represented by a chemical formula. Okay, components of a mixture always retain their physical and chemical properties, and the examples of the mixtures are blood is a mixture because it is a mixture of white blood cells, red blood cells, tissues, plasma, etc. While alloy is also a mixture. It is a mixture of two metals and metal with non-metal, and in non-metals we have only carbon. Okay, the next topic is compound. Compound is vice versa to the mixture. Okay, it is formed when two or more than two substances chemically combine with each other. Okay, components of a compound cannot be separated by simple separation techniques like these. Compound cannot be separated by evaporation, by simple distillation, and etc. There is a fixed ratio by mass among the components of a compound. Like, for example, what does this mean? This means Na, two, what can be the example, like NaCl. There is 1:1 mass ratio. Okay, and you can take other examples like H2SO4. There is 2 and 4. Okay, so we can predict the mass ratio. Okay, while in the mixture we cannot predict. In the next heading is compounds can be represented by the chemical formula. I have write it again, so only we have chemical formula. Chemical formula. Okay, next. Components of a compound do not retain their physical and chemical properties. Means they have completely changed when they react with any element. Okay, so examples are ethanol, limestone. Ethanol has a formula, and the formula is C2H5OH. Okay, and limestone has also formula. Now we have past paper question, which is a pure compound. Now you have to know what is compound. Right now we have studied what is compound. it is formed when two or more than two substances chemically combine. Okay, so, and the main thing, it is represented by the chemical formula. So dry air have no formula, steel have no formula, petrol have no formula, while ethanol has a formula, and the formula is C2H5OH. Okay, now which statement about the boxes P and Q are is PQR is correct? Option is saying box P contains two compounds and box R contains two elements. So this option is wrong, because box P contains two elements. Okay, because these are the two atoms of the same element, so it is element. Same atoms of the element, same atoms of the element, same atoms of the element. So these are the elements, not a compound. While in this, these are not elements, these are mixtures, because here is something different, here is something different, here is something different. Okay, so it is not a element. The option B is saying box P contains two elements, okay, and box Q contains a mixture, while box Q is not a mixture, it is a compound. Okay, because here there are two different and they are similar, so it is not a mixture. Okay, box P contains, option C, box P contains two elements, okay, and box Q contains compound, so this one is right option. Moving forward, which diagram shows a mixture of an element and a compound? Mixture and element, or element and a compound. So these are all the elements, no compound here. These are all the elements, no compound. All the compounds, no element. So here this one is element, compound. So here is a mixture of compound and an element. Okay. Now, steps for balancing the chemical reactions. You have to learn these 5 steps and you will be able to balance any kind of equation. Okay. Now, balance the metals first. Whenever you saw or you see any kind of equation, first look, is there any metal? If is there any metal, then balance the metal first. So on the second, balance the non-metals which are not diatomic. Which are not atomic means carbon, sulfur, phosphorus, etc. Then balance the non-metals which are diatomic, like nitrogen, chlorine, bromine, etc. Then balance the hydrogen and then balance the oxygen. If you do not remember all these steps, then must remember the first step and the last step. First balance the metals and at the end balance the oxygen. Okay. So here we have some examples of balancing equations, and some of these I have solved and the others are your assignment. If you have any, if you face any difficulty in solving these, you can ask me in the comments. I will reply to you. Okay. So the next topic is types of chemical reactions. Okay. Addition reactions or synthesis or combination reactions. In addition reactions, two or more than two elements or compounds chemically combine with each other to form a single product. What the mean addition? Means gather something. Okay, so mostly addition reactions are exothermic. Exothermic means which releases heat. Okay, examples are nitrogen and hydrogen, two elements combine together to form single product, and that is ammonia. So it is a addition reaction. Here CaO and CO2 combine together, a mixture and element combined together means there are two things on the reactant side, and at the product side we have only one thing. It means two things are combined to make one thing, like two reactants are combined together to make one compound. So it is these such kind of reactions are addition reactions. Okay, now decomposition reactions. What the mean decomposition means? Decay. In decomposition reactions, a single reactant is decomposed into two or more than two products, vice versa to the addition reaction. Okay, like CaCO2 decomposes to CaO and carbon dioxide. Similarly, lead nitrate, when we decompose a lead nitrate, it goes to lead oxide and nitrogen dioxide and oxygen. Okay, and these are endothermic in nature, means they absorb heat. What are the exothermic and endothermic? We will discuss these in the next chapter. Okay, single displacement reactions, let's discuss it. In single displacement reactions, more than one compound plus element. Okay, this is not for you. More reactive element displaces the less reactive element from the salt solution. Let's discuss this, and these are exothermic. Let's discuss what is definition saying. Like Mg plus CuSO4 goes to magnesium sulfate and copper. Observe this. Magnesium displaces the copper. So to find or to remember what is the most reactive metal, we have to learn a reactivity series, and we will discuss this reactivity series in the next chapters. When we will be in the chapter of metals, we will discuss this thoroughly and the role of the reactivity series in chemistry. Okay, right now here magnesium displaces the copper because magnesium is more reactive than copper. Okay, so it displaces the copper, so it is single displacement. Okay, here Br, we have discussed it in the previous lecture that chlorine is more reactive than Br, so chlorine will displace the bromine and KCl will be the next or new product. Okay, so I hope it will be clear to you. The next heading is double displacement reactions. Let's discuss it. In double displacement reactions, both positive ions or both negative ions exchange their positions. Okay, let's see. These are exothermic reactions. Okay, you have to remember these are exothermic reactions. Here, AgNO3 means silver nitrate plus sodium chloride goes to silver chloride plus sodium nitrate. Okay, what is happening over here? Na displaces the Ag, means sodium displaces the silver because sodium is more reactive. Okay, here nitrate will be displaced by the chlorine. Okay, so this is double displacement because both positive and negative ions have changed their positions. Like we have here AgNO3, but in the product side we have AgCl, so the position has changed for the both of the elements, so therefore it will be double displacement reaction. Okay, now neutralization reaction, in which we have acid and base and product are salt and water. Neutralization reaction or double displacement reaction, we can also call it double displacement reaction. In neutralization reactions, acid and base react with each other to form salt and water. Neutralization reactions are exothermic in nature. Examples: HCl and NaOH. HCl is a base, HCl is a acid, and this one is base, and it is a strong acid, strong base. Now we will discuss in the chapter of acid bases what are strong bases and how we came to know it is a strong acid, strong base, weak acid, weak base. We will discuss it thoroughly in the next chapter in the future lectures, which I will upload very soon. So HCl plus NaOH, NaCl, salt and water. Okay, neutralization reaction occur over here. Next heading is combustion reactions. Combustion means exothermic. All the combustion reactions are exothermic. In combustion reactions, an element or a compound is burned, oxidized in limited or excess supply of oxygen. This oxidization and reduction, all these things we will discuss in future lectures, okay? And we will discuss them thoroughly. So the example of combustion reaction is sulfur plus oxygen, sulfur dioxide. CH4 plus O2 goes to CO2 plus 2H2O. Types of reactions worksheet. So I have solved it for you, and if you feel any query, any difficulty, you can ask me in the comments and I will reply to you as soon as possible. Okay, so do this on their own. It will be a practice for you. How to write a chemical formula for a compound. So this is the table, you have to learn it. Okay, these are the formulas, you have to learn them by your heart. So, and this is very important table, you have to learn it, and it is very necessary to you learn it, because without this we cannot make chemical formulas. Okay, so to make chemical formula, first write down the symbolic representations of the each element or compound. Write down the charges at the top of the species. If the charges are same, then cancel out the charges, otherwise cross multiply the charges. So let's do the examples. Silver nitrate. Firstly, write the symbol of silver. You can find it from the periodic table, Ag, and the charge is +1. Okay, nitrate, NO3 minus -1. To remember the charges of these: nitrate, sulfate, carbonate, sulfide, nitrite, you have to learn the table which is above this page. Okay, so now the charges are same, so we will cancel them out and we have the final product, and it will be AgNO3, means silver nitrate. Okay, hope it will be clear to you. Now the next example is calcium phosphate. So firstly, write down the symbol of calcium and phosphate. Calcium is Ca plus 2 is the charge, okay, and phosphate is PO4 -3. Now the charges are not same, so we will cross multiply these. So Ca3 PO4 whole twice. We have to put the brackets because PO4, the whole PO4 has 2, not only the oxygen. Okay, therefore we have to open the brackets. Hope it will be clear to you. So these are the similar, so I'm not going to do this. You have to do these examples as practice, and if you have any query you can ask me and I will reply to you. Reaction types, as we have previously done this topic, addition reactions, single displacement reactions. So I have done this for you. You can do these by their own, and if you feel any difficulty and if you have any query, you can ask and I will reply to you as soon as possible. Okay, and these are basically very important examples. Okay, I'm not going to do this because we have already discussed in the previous topic. So this is the most important topic of this chapter, and it will not help you in this chapter only, it will also help you in the next chapters, like in acid bases, in ATP. So I can't tell how many advantages of learning this table. So nitrates, all the nitrates are soluble. Group 1 salts, all the group 1 salts are soluble. All ammonium salts are soluble. Carbonates are all insoluble except group 1 and ammonium. Halides, all halides are soluble except Cl except Ag and Pb, means silver and lead. All halides are soluble except silver and lead. What are the halides? Halides are basically halogens. Cl, Br, F, fluorine. These are the halides. Okay? Sulfates. There is an acronym for the sulfate. All the sulfates are soluble except Aaj ka Bahawalpur. Okay? Ag means silver, Ca means calcium, Ba means barium, and Pb means lead. Okay? Phosphates. The rule for the carbonates and phosphates is same. Okay? Now, solubility of acids. All the acids are soluble. All the hydroxides are insoluble except group 1, group 2, and group 2 only Ca, Ba, and Sr. In group 2 only the hydroxides of these elements are soluble, other are insoluble. And ammonium, NH4 hydroxides are also soluble, but these are partially soluble. There is same rule for the hydroxide and oxide. Okay, so next, ionic equations. Balance the chemical equation by using suitable coefficient. Firstly, you have to balance the equation. Okay, and the rules for the balancing the equations we have studied. Write down the state symbols of each component of the equation. Convert the aqueous solutions into ions. Do not ionize the solids, liquids, and gases. Cancel out the spectator ions. Spectator ions mean same charges or same ions on the both sides of the reactants and products. The same ions on the both sides means on the reactant side and the product side, they will be cancelled out. Okay, rewrite the ionic equation. So do this example. AgNO3. How do we know that it is aqueous? How do we know that AgNO3 is aqueous? Because all the nitrates are soluble. Okay. How do we know that this calcium chloride, it is a salt and it is soluble? As we have studied that all the halides are soluble except Ag and Pb, so it will also be aqueous. AgCl, it will be the insoluble one, because right now or just before a while we have studied that all the halides are soluble except Ag and Pb, so it will be in the solid state because it will not dissolve in water. Now nitrate, all the nitrates are soluble. Okay, we have write down all the ions. Okay, Ag plus 1, NO3 plus negative 1, K plus positive 1, Cl negative 1. We will not ionize AgCl because it will not ionize or it will not dissolve in water. It will not in the aqueous state. That's why we cannot put charges on it, because solids have no charges. And here we have KNO3, and now NO3, NO3. These are the spectator ions. These are same on both sides. Okay, so cancel them out, and the remaining equation, we have to write the remaining equation. Ag here, Cl goes to AgCl. So this is the concept. Okay, and it was not too difficult, so much difficult, and it is basically you have to learn the basic steps which I have told earlier in this lecture. Okay, so here is a past paper section. Let's do these questions. The carbonate, chloride, and sulfate of a metal are all soluble in water. What is the metal? Barium. The carbonate, chloride, and sulfate. Basically the question is saying which one element has these compounds which are soluble in water. So potassium, it is a group 1 salt. So carbonate, we have learned the rule that all the carbonates of group 1 are soluble, all the chlorides are soluble except Ag and Pb, all the sulfates are soluble except Ag, Pb, Ba, and one was more. Okay, so potassium is the answer because all these compounds of potassium are soluble in water. Which row shows the correct state symbols for the reaction between calcium carbonate and the dilute hydrochloric acid? The conditions are room temperature and pressure. Okay, calcium carbonate, because we have studied that all the carbonates are insoluble except group 1, group 2. In group 2 only we have Ca, B, A, S, R. Okay, only these elements, compounds of group 2 are soluble. So at room temperature, calcium chloride will be solid, HCl will be aqueous, CaCl2, it is a soluble salt, so it will be aqueous. Okay, H2O liquid and CO2 is a gas at room temperature. So D is the answer. Okay, next question. The next question is, magnesium will react with aqueous copper to sulfate to form copper and aqueous magnesium sulfate. What is the correct equation for this reaction? Okay, the question is saying that magnesium Mg reacts with copper to sulfate CuSO4. Okay, so what will the process? Magnesium is more reactive than copper, so it will replace the copper, as we have studied in the single displacement reaction and double displacement reaction. So MgSO4 and copper. So this will be the answer. Okay, so A is the answer. Okay, A is the answer. Now the last MCQ is, how many elements combine to form a compound ammonium sulfate? First write down the formula of ammonium sulfate. Okay, NH4. Okay, this is the symbol of ammonium and the symbol of sulfate is this, because right now we have studied how to make chemical formula SO4 -2 and its charge is +1. I am saying again, to remember the charges or to learn the charges, you have to do the table which I appointed to you. So the charges are not same, cross multiply these. So NH4, we have to open the brackets because the 2 charge is for the whole ammonium. If we will not open the brackets, the 2 will be here. It means it is only for H. So that 2 is not only for H. Okay, it is for the whole ammonium. So okay, NH4 whole twice and SO4. This is ammonium sulfate. Now count the elements: 1, 2, 3 and 4. So 4 is the answer. This one is not the answer. Okay, 4 is the answer because 1 nitrogen, hydrogen, sulfur and oxygen. This is ammonium sulfate. Okay, so this is the today's lecture, and I hope it will be clear to you and you will be able to differentiate between the types of reactions and how to make chemical equations and how to balance ionic equations. Okay, so thanks for watching.